I wanted to know, like, how many of you are already working and how many of you are students?
I'm a working professional. Hello.
Yes, yes, yes.
I am also working, sir.
Yeah. So basically,
Yeah.
I am also
supervision
working.
part of the PCB manufacturing, but I just
Okay. So three. Okay, fine. So fine. Yeah. I assume that majority of you are working. So you're Manav, right? You said that you are a PC. You are already into this PCB manufacturing process, right?
yes, yeah. I'm working in the supply chain part, basically in procurement.
Procurement in the sense like PCB
Yeah.
materials
No,
and the components,
electronic components. Yeah.
electronic components. Sure. Okay. Yeah. Okay, this course is basically about this. This is a subset of the hardware design mastery. So initially, what happened? We thought that we wanted to make a course on the hardware design itself because we are not getting people for the hardware design. So and then teaching hardware design is, first of all, it is very difficult, and students from EC and EE background, they are actively interested in learning this. But even though we say that this is hardware design, it is very difficult for us to teach. So still that process is still going on, that complete hardware design we are making that course. And the subset is the PCB design. It is like two faces of the same kind, hardware design and the PCB design. If at all you want to become a hardware design engineer or a PCB design engineer, you have to learn this PCB design itself. Okay. That is the fundamental. Based on that, we started all this. Now, question is like, why can't you get into any of the industry and then you can learn the PCB design? There also they'll be giving some trainings. What I have seen is like majority of the companies, when they hire people, they give certain training videos and then they give some small assignments. So and they will not be a part of full picture. One more point is like, if it is a software development, fix, you can give an next version or something like that. Whereas in this industry, PCB design industry, cost is directly involved. So in any of the software industry, cost is not indirectly involved. Here, the cost is directly involved. You know that in any of the product development lifecycle, it consists of multiple stages. So why experienced PCB design engineers are required? Assume that during the production and testing, if we started from the concept, we did the design, we developed the PCB, and then we sent it to the production. At that time, someone has found out that there is a TVS diode which is little bit far from the connector. So whatever the energy that is giving as an ESD, electrostatic discharge, it is flowing in. It is flowing into the complete one particular layer itself, and then the TVS diode is little bit far from the connector, so it cannot able to bypass that particular energy immediately. So they found out at this point. Imagine they have to again reinvest everything, including the time itself. Whereas an experienced PCB design engineer knows, okay, here I have to place the TVS diode, and this is the orientation, this is the thing, that is the impedance profile, those things like that, and all that. So considering that, that's why experienced PCB design engineers have more value in our cycle, and that's why it is very important for you to learn it as as early as possible. Next question, like, why you want to learn PCB design? Since majority of you are a professional, you must know the basic understanding of the PCB design to grow in your career. Also, assume that you are a hardware engineer, you want to develop some particular circuit on particular certain conditions and all. You cannot keep on asking a PCB engineer, okay, please do this PCB for me or something like that. You should be in a position to make your own PCBs. Majority of the companies, this is what happened. This is what happens. Even I worked in my previous companies also. What happened is like hardware design engineers will develop a certain design and then they give it to the PCB design engineer. PCB design engineers will be like heavily loaded all the time. So what they used to do, they used to delay that. So because of that delay, right, the project timeline will get affected and there is going to be a bad name for the hardware engineers. Whereas if you are a PCB design engineer, you need to know in and out of that a particular product, a particular PCB, especially your design. Otherwise, what happens? You will it can fail anywhere. So that is most important in here. So in order for you to grow in your company, as well as in order for you to make the product right at the very first time itself, you need to learn this. Now in this course, in this course, what all we be dealing actually, this is an advanced PCB design. There is something called as master PCB design also, that is very advanced. I'll show you later. So in this PCB design course, that is advanced, so we'll be starting with that product development process itself, like how the product from the requirement till that PCB design, like how it comes to you actually. It also starts from the system architecture, and then how is anything that you do impacts on the cost as well as the reliability. We have a specific standard that I'll be telling. So there are certain reliability uh, bifurcations wherein your product will belong to certain reliability class. So based on that stringent constraints, based on those reliability class itself, we should be able to design. And then the manufacturability also, so we'll be talking about that. Like I said, IPC standards and other standards also, like IEC, that is electromagnetic compatibility standards. Most importantly, it is very we will explain like how to read a data sheet and interpret it. That is very important, whether it's a component data sheet or a material data sheet or a PCB particular um, manufacturer data sheet, whatever it is, that you should be able to understand and interpret, and you should also translate whatever you have understood in your design. And in the schematic design, you know that anyone can draw the circuit. It is not a big deal. Like you have certain you have a battery, you have a resistor, and then you have a LED. Assume that is a simple circuit, but readable circuit design is very important. There are multiple ways to do that, and that will be showing here. And then the signal flow, like how from left to right, if I'm reading something, like how I'll read the circuit, how I'll understand that. Because if you say that this is the design, many of the people, like from end to end, majority of the people will ask the schematic itself. They're not going to ask your PCB, because very little people will understand the PCB. So if at all I'm thinking in the if at all I'm thinking in terms as a circuit, I need a schematic, not the PCB. So schematic should be very, very neat and very, very readable. Okay, and then it should not give any sort of error. And you should know how to detect the error in the schematic design itself. That and all we'll see here. And then component library and footprint engineering. This is the most underestimated part of our complete uh, PCB engineering. What is happening is like we feel that whatever we import the third party component is correct. Where you will realize this mistake once the board comes out, the component is not fitting properly, the orientation is not proper, then only we'll understand. So how to detect all those things at the very early stage, that we'll be dealing here. And then the layout engineering, like if you have a schematic, if your schematic is finalized, if you a product is finalized, if your design is finalized, okay, let us start the layout engineering. In that sense, we will start like how do you do the board setup, what are the constraints, what are the materials used, what are the properties, and then the layer stack up, like how do you design that layer stack up itself. Assume that someone says that okay, I have around 20 components, I'll design like 10 layer. So you should be in a position to say that no, that is not required. Someone is like, yeah, I have around 200 components, let us do please do it in 2 layers. You should know like how many layers is required to do that and all that. And then advanced component placement strategies, like why you have to place certain components there, how you have to place, and all that you are going to learn in here. As well as routing and signal integrity, like routing impedance profile, like what is that impedance actually means, that characteristic impedance, the clearance constraints, the width, what are design rules, how you are going to implement all those things, what is differential pair, so many things that is here it is involved, especially the signal integrity and EMC parts, like crosstalk, ground noise, many other things from the signal integrity. And then the validation things, like how do you check that, how do you debug a DRC failure, like design rule check failures and all that you'll be learning here. Okay, the other things are some things are smaller and all that. And then the manufacturing and fabrication output, like how a manufacturer understands your design. You send a Gerber file to him, so what he will do with that Gerber file, so what is the design for manufacturability, what he will check, and what things that he will ask you. So how do you generate the bomb, how do you generate the drill files, and silk screen, what is the silk screen requirement, how do you see, all that you are going to learn here. So, and then what is the additional skills, like I explained, the data sheet and circuit level understanding, it is required. If at all you are designing a PCB, you should know what a circuit does. So how do you understand that, even though you have no experience? So that also you'll be learning, and especially here, EMI and EMC, that is very important. Then most importantly, like I said, EMC we are covering here, that is electromagnetic compatibility, and then signal integrity, PDN, and all that, and why it is important. So signal integrity, power integrity, and it we will be discussing here on a basic terms, because it's an advanced PCB design course. In the masters, we'll be going in very depth actually. So that is very important here. And then if at all you design some PCBs, and how do you order that? Like, a manufacturer will take your PCBs. What is his point? He has to make the cost more. What is your point? You have to make the cost less for more number of PCBs. So how do you do that? And DFM and DFT basics and all that manufacturing process. Assume that if at all you want to pursue a career in this PCB design itself, like how do you prepare your resume accordingly? And then even though you know everything, you should know how to explain it to someone. So that is also will be covering. And PCB test, like ICT, FCTs, shorts and opens, and board bring up sequences, like how it is done. I think you have done PCB, like how they are going to test it, how hardware engineers are going to test it, and then boundary scan conditions. Like at the whatever is required, we are going to tell everything. Some of the standards like IPC 735 and IPC 2221B. This is very important standard. This is generic standard. So majority of this course is come around this standard only. Then IPC 610A, that is acceptability standards. You have built some PCB and then you are going to send it to the customer. So he has to accept that, okay, this PCB design, this PCB belongs to this particular class, and these are my requirements, which I can, based on that you have designed, and I'm going to accept it based on this standard. So you should know this also. This is very important. 61000, some 6 dash X. So this is complete. This 61000 is complete EMC standard. So you are going to learn about emissions. You are going to learn about immunity, like different types of immunity, like EFT, electrical fast transients, surge immunity, and then electrostatic immunity. So these things and all you are going to learn. Not those tests and the in depth of that particular thing, but based on that, how you are going to design your PCB. And then there are so many courses available online. So why you have to choose a particular professional itself to learn this? See, first of all, in online videos, assume that they are going to make one board. So their complete focus will be on that board itself. So whatever is required for that board, they are going to teach. Apart from that, you have to learn. Here we will teach definitely whatever is required of for that board, as well as whatever is required for you to build any boards, that we are going to teach in here. For during that online trainers, what their problem is, they have certain specific timeline. For any video there will be certain specific timeline. Here there is no timeline. You can ask doubt anytime. There you cannot go, when you're seeing the video, you have some doubt, you cannot stop it and then you cannot ask him there. Whereas here you are paying us, so you have all the things for us to ask. So we'll clarify it then and there only. And especially EduCADD, I'm working here, especially in this. Whatever the doubts that you have, everything is sorted out very smoothly. I have seen people like, I cannot come at this time, I cannot, no, not here. So we have been doing this course for quite a long time, so we know how to deal with these things. There is no conflicts only, so we know how to sort the things very smoothly. And like it is written there, you don't become hardware engineer by watching videos. You have to build PCBs and you have to understand how do you build it in the right way. That is very important. Okay. Now, after doing this course, what you can do actually, you can design any type of PCBs. There are multiple uh, different types of PCBs actually. One is analog type, another one is digital PCBs, mixed signal, power electronics, IoT, embedded. So each and every type of these PCBs has its own design philosophy. For example, I am working on an analog board. So I know that in this board, or in the analog section of my board, this the noise should be very minimum. So how I'm going to segregate that, how I'm routing that signal so that I'm avoiding majority of the noise. In the digital, grounding is very important. Whatever that switching noise and the other things that is getting generated on the board, how I'm going to ground. In mixed signal, you put analog and digital, you are like almost literally cooked. So how you are going to design that, that is very important. In power electronics, the heat will be generated, the thermal things are going to come in place. So that's why, so every type of PCB you are going to study and you are going to do it in here. And then you have very full grip of hardware design and PCB design. See, PCB design is not only about the tool. Actually, people say that whenever they say PCB design, we are going to teach Altium. It is like, understand that whenever you are going to learn some driving, right, you are going to ask in the school that I want to learn driving. You are not going to ask like I want to learn Swift car, right? In the same way, here you are going to learn PCB design. Tool Altium is a car that you need to learn that tool. Exactly. So that is why you are not going to ask like I need to learn Swift, right? So if once you learn the driving, you can drive any car. In the same way, once you learn the design itself, how do you do the PCB design, you can learn any different tool. And Altium, we are taking it to learn the PCB design. And then you can crack any of the hardware and design and PCB design interviews. This one I personally guarantee you. Okay. And then of course you can do your own projects based on freelancing. It is completely up to you what do you do, but when it comes to board, you should be able to design. This is what my objective is. Okay, any freelancing project, and then you can also make money there. Okay, and also you can review the other people design, so that is also very important here. Now, for example, when we say all that, okay, what PCB design, that, this, and all, none of your online instructors or whoever it is, they are not going to show this particular eye diagram. They're not going to show how do you do the jitter budgeting and all that. So that we will be explaining in here. And assume that you messed up some part of that signal. So we will explain you like why you should like this. So we will like, okay, we will show you certain things and all that. See, this is a magnetic probe that he is putting, and you can see that radiation something here. So the what is the issue could be here, and all that we'll be explaining because of the ground areas and all that, ground loops and all that. And you see here this PCB like how it is segregated. Different portion of this PCB is segregated with different parts. Actually, for power section, one part, digital is one part, analog is one part, and everything will get interconnected. It's a beautiful process. Actually, you need to understand it completely. And once you make a professional PCB, it should look like this. So I don't know what level you are. Each of you, like majority of you said that you are working. So if at all you can able to design a proper PCB, it should look like this. In terms of careers, I need not to explain like what is the demand for PCB engineers. So we have less jobs, sorry, we have more jobs and less people only. So you always have a demand. One more important thing, can AI replace hardware engineers and PCB engineers? The straight away answer is no. What AI can do is it can assist. Like I said, PCB is not just do connecting from one point to another point. It involves intuition. It involves your skill. It involves your practice. It involves the knowledge of so many things. It is also an art. Like how do you draw that tracks and all. So like not everyone can do this, but as well as AI can also not do this 100%. Okay, ma'am, yeah, you can take it from here. And before this, just a second, I wanted to
Yeah.
show you. Just a second, ma'am, just a second. See, this is just a representation of what we are going to teach. There are so many other things. Just a second. There are so many other things that we'll be teaching. See, professional design course. So I cannot put everything in that PPT. So I just put whatever is required. Moreover, understanding is very important in this. And in a very, very similar way, you can see here. You can see here like these two we are still working on. You can see there are two PCB advanced PCB design and then master design. There are two courses. So what is the basic difference? So I'll just show you. See, this is what you're going to learn in advanced PCB design course. Like you should be able to do any sorts of product level boards. Okay, and you will be actually doing these boards. You will be doing these boards. Okay, PCB design, it is like a HMI, like this display modules and all, the single board computers like Raspberry Pi, BeagleBone, and all that. So This is next level things only. So if you have any knowledge of PCB design, you go for this. If you do not have any knowledge of PCB design, you please go for this. Yeah. Yes, ma'am. Like, yeah.
Sure. Thank you so much. Yeah, the last section is the pricing. Before we go ahead for that, any technical questions anybody has?
Yes, please. See, you are opting for this course means like you will be like thinking like what could be this, what is this, and all that. So please ask. Okay.
You can keep your questions ready. In the meanwhile, I'll just brief about the prices here. So I can, because you can see here, we have two modules which we are already giving the training, Advanced PCB and Master PCB. So Advanced PCB is a 60-hour course which will go up to 2 months, 2.5 months. Okay, and because practice sessions, everything will be there. The cost of this in the actual market is 30,680. Whereas at EduCADD, we are offering at 18,480 for not 8, which is close to 40% discount we are giving. Master PCB course is a 120-hour session, which can go up to 3 months, 3.5 months, and the price is 61,360. Here we are offering at 36,816, which is again at a 40% discount. The other two, what you can see, third and fourth, advanced embedded hardware, professional embedded hardware, we are working on it. There are a lot of inquiries coming in. The syllabus is in progress, but we're not able to get time on to start off with the sessions because we are so much occupied with the master's course itself, the second option. The batches are coming, the inquiries are coming back to back for that. So by the time we have to complete this entire schedule for advanced and professional, we are taking a little time, which will be done in a month's time or so. Even that will be ready, and we are having a lot of inquiries for these two. So the batch will be starting soon, just to know everyone. Probably by July 1st, we are starting this batch because simultaneously we'll be having advanced and master PCB. Probably if at all we're going to have two, it will be like Monday to Friday batches, and also weekend batches. They're only on Saturday, Sunday. Okay, 3 weeks a month. Okay, 3 weeks a month. We are going to have only Saturday, Sunday. That to offline classes. You can come to our center in JP. We are in JP Nagar near metro station. I will share the location. And if you're going for online classes, it will be evening 8 o'clock. 8 is one, 8:30. I think we'll schedule that accordingly. So this is the online batch. Okay. And about the softwares, I'm sure you would have got to know two softwares will be helping you in installation and post completion of the course. Not even post completion, before that, we will help you prepare your resumes and mock interviews. Prepping you up for the interviews, everything that will be done from our end because we also have an in-house HR consultancy called JobCut where all our students who pass out, yeah, every batch, at least, example, out of 10, 8 people get placed through EduCAD itself. It could be any course, PCB or triple E, not just electronics or digital marketing, AutoCAD, because we have a wide variety of network and tier 1, tier 2 companies tied up to. So that is the kind of flow it happens. As soon as you get through the course, then you're going to complete the course, another 80% is done, you will be start preparing for the interviews. Yeah. So that was about the price, course details. Anybody has any questions regarding course timings, or you want to come and meet us personally? You can definitely do. I'm dropping you my number here.
So all of you are working on electronics related field itself, or how? Manav, I got to know, and other people. Rupashri, I know. Manav also, I know, and others.
Yeah, I am from electronics background.
You're working in electronics only.
Yeah, I'm an electronics engineer.
Okay, like what exactly that you are doing? Hardware design engineer or something?
Yeah, I have started my career with hardware design, but
Okay.
having almost 3 years of experience,
Mm-hmm.
I know the basic designs, PCB design, but I want to learn more about that, like in depth of stack ups and other things.
Mm-hmm. Okay, fine. So you are working as in hardware in embedded domain or in automotive or something like that?
Yeah, it's in an embedded IoT domain.
Okay, fine, fine, fine. Nice to know, Shivram.
Yeah,
Sri Ram, right? Yeah. Okay.
yeah, Sriram.
Yes. Anyone? You're working as a hello Manu. You're telling that. Yeah.
Yes, sir.
Yeah, you're from Triple E background, working as a faculty coordinator engineer. Okay, where? May I ask?
In brigade, sir.
Brigade. Okay, fine, fine, fine. So you have okay, nice, fine, sure. So you have experience with respect to PCB designs earlier, or you're starting
No,
now?
sir.
You're
Yes, sir.
starting now.
Static.
Okay, fine, fine, fine. Nice to know. Yeah. Thanks, Manu. Anyone else? Yeah. Currently, two batches running actually, and one more ma'am is going to start. So you have to talk to her. Okay. If in case if you have any questions, also you can come back to us. So yeah, we'll be
Sure.
there to sort it out. Yeah. Thank you.
Yeah.
Thanks a lot.
Okay, registrations will be closing soon, so you can contact myself, Hema, this is my number, or Jamuna. So by Saturday we'll be closing the session, and by July first week we're planning and sorting it out, having the installations, everything ready. July first week we'll be having the first week kind. We'll be having the classes starting, online classes, offline classes. Anybody wants, you can contact. Okay. So I believe there is no other technical questions. Anybody? Yeah, if you want to talk to Bharat sir personally also, you can let me know. We can connect offline. Okay. Sriram sir, any doubt? Rupashri?
Okay, ma'am. Thanks. Like I had to leave. I
Sure.
had, yeah. Thank you.
Sure,
Bye.
sir. Thank you. Thank you, everyone. Thanks for your time. Bye.